Given the functions f at x is equal to the square root of x and g at x is equal to x minus 5, find each of the following. First, we're asked to find the f plus g function and then its domain. Let's recall that f plus g is shorthand for f plus g of x, which is shorthand for f of x plus g of x. So in order to find the f plus g function, we're simply going to take the f of x function, which is rad x, and then add to that the g of x function, which is x minus 5. And now, this is functional notation, of course, written in a shorthand form. F plus g is the same thing as y is equal to. So this might as well say y is equal to rad x plus x minus 5. And looking at it in this form, it's easier to see that we're not going to be trying to solve for x here. This is a two-variable equation, and a two-variable equation is one that has a graph. So once we add these two functions together, that's it. This is the f plus g function. It's something that can be graphed. It's not something that we're going to try to solve for x. But now in order to find its domain, let's recall that that's a two-step process. The first thing that we want to do is we want to find the domain of f and find the domain of g. And then we want to find where those two domains overlap or intersect. So let's begin with the domain of f. F at x is equal to the square root of x, and in order to find the domain of a radical function, we simply take the radicand and set that greater than or equal to 0. In this case, our radicand is just x, so x is greater than or equal to 0. So the elements that are allowed to be plugged into f are just the positive x's. So let's sketch that domain here on a number line. The domain of f is all x values that are greater than or equal to 0. So we have found the domain of f. Now let's find the domain of g. G of x is x minus 5, and x minus 5 is a linear function, which is a special case of a polynomial, and all polynomials have domains that are unrestricted, all real numbers. So on our concept drawing over here, we'll see that the domain of g is unrestricted, all real numbers. And now we want to figure out where those two domains intersect or overlap. These domains are going to overlap from 0 to positive infinity. Any x value that is greater than or equal to 0 is going to work in f, but it's also going to work in g. So that's the intersection. And now let's clearly state the domain of f plus g in interval notation, which is going to be from 0 to positive infinity. The intersection of the domain of f with the domain of g. Now let's do this again for the f times g function. Recall f times g is the same thing as f times g of x, which is f at x times g of x. So the f times g function is then going to be the f of x function multiplied by the g of x function, which is x minus 5. And again, this is the end. We're not trying to solve for x here. This is a function that's going to have a graph that is written in functional notation. So now in order to find its domain, again, we're going to start with the domain of f, which we've already found to be from 0 to positive infinity. And then we're going to look at the domain of g, which again, we've already found to be all real numbers. The domain of f times g is just going to be where these two domains intersect, which is, again, from 0 to positive infinity. We get the same domain here as we had in part A. When we try to find the f divided by g function and its domain, this is where we're going to end up with the additional exclusion. So first let's just find the f divided by g function. Remember, f divided by g is shorthand for f divided by g of x, which is shorthand for f of x divided by g of x. So the f divided by g function is just going to be the f of x function, which is square root x, divided by the g of x function, which is x minus 5. And so now, in order to find its domain, we again are going to consider the domain of f, which we have found to be from 0 to positive infinity, and the domain of g, which we have found to be all real numbers. But now we're going to have that additional exclusion, which is to say that we're going to eliminate any x value that would cause the g of x function that occurs in the denominator of the fraction to be equal to 0. And as we can see, 5 is the x value that would cause the g of x function to be 0, so that then has to be left out. So before we write this domain in interval notation, let's first look at all of this on a number line to get a clear understanding of what's going on here. So we have the domain of f, which is from 0 to positive infinity. We have the domain of g, which is all real numbers. And then we have the value 5 that needs to be excluded. So we're going to chop out the 5. So let's now write the domain of f divided by g in interval notation. We start with this intersection that is the domain of f intersected with the domain of g, meaning that we are going to begin with x is equal to 0, and then we're going to go out to positive infinity, except for the fact that we exclude the 5. So we have to stop at the 5, leave it out, pick back up at the 5, and then go off to positive infinity. And then this is the domain of f divided by g.